we're excited to announce 2 missions of discovery. These missions will help us learn about the infancy of our solar system, a period just 10 million years after the birth of our sun. The first mission is called Lucy. Lucy will visit 6 diverse bodies, known as Trojans. These Trojans orbit the sun in swarms in front of and behind Jupiter, trapped by Jupiter's gravity. We know very little about these objects. They may be captured asteroids, comets, or even Kuiper Belt objects. The second mission is called Psyche. Psyche will take us to a very large and rare asteroid made of metal. 16 Psyche is the asteroid. It is made of metallic iron and nickel, much like the Earth's core. Scientists believe that Psyche may be exposed core of a planet that was once the size of Mars, but it lost its outer rocky layers due to a series of violent collisions. Lucy launches in 2021 and Psyche in 2023. Come along for the ride and follow these and other planetary missions on nasa.gov.
Asteroid Psyche is filled with precious metals and could worth more than 10 trillion US dollars. New measurements of its surface temperature have been confirmed. Psyche is a 124-mile wide space rock orbiting the Sun in the asteroid belt, a donut-shaped region of space between Mars and Jupiter containing more than 1 million rocks. NASA is sending a mission to study the metal-rich asteroid in 2026 in an effort to determine its origin, with some speculating that it was the core of an early planet. To help with this task, a new temperature map was created for Psyche by a team from Caltech in Pasadena, California to provide detailed information about its surface properties. Psyche 16 was originally discovered in 1852 and is thought to be the remnant of a protoplanet destroyed by a runaway collision when the solar system was forming. Unlike other ice or icy objects, Psyche 16 is believed to be made of mostly iron and nickel, and could have a potential mining value in the trillions of dollars. Before the NASA mission, the team from California conducted a close examination of the millimeter wavelength radiation from the asteroid. Psyche is the largest of the M-type asteroids, a mysterious type of asteroid believed to be rich in metals and therefore likely to be core fragments of protoplanets that broke apart when the solar system broke up. Heaven formed. We think that fragments of the core, mantle, and crust of these objects are still present today as asteroids. If that's true, it gives us the only real opportunity to directly study the cores of planet-like objects. Studying such relatively small objects so far away from Earth, with Psyche at a distance of 200 million miles, poses a significant challenge for planetary scientists. Typically, thermal observations from Earth, measuring the light emitted by an object itself rather than light from the Sun reflected from that object, are at infrared wavelengths and can only produce images of 1 pixels of the asteroid. However, that single pixel contains a lot of information about an asteroid, such as its thermal inertia or the rate at which it heats up in sunlight and cools in the dark. The 66 radio telescope system allowed the team to map thermal emission from Psyche's entire surface at 18-mile resolution. In the data set, each pixel is 18 miles by 18 miles and when combined produces an image of the asteroid consisting of about 50 pixels. This provides significantly better resolution and data than typical single-pixel images obtained of the surface of these asteroid belt space rocks. The study confirms that Psyche's thermal inertia is high compared to that of a typical asteroid, suggesting it has an unusually dense or conductive surface. When DeClear, Cambiani, and Shepard analyzed the data, they also found that Psyche's thermal emission, i.e. the amount of heat it gives off, was 60% of what would be expected from a typical surface with thermal inertia. Because surface emissivity is affected by the presence of metal on the surface, their findings indicate that the surface of Psyche is not less than 30% metallic. The findings support alternative suggestions for Psyche's surface composition, including that Psyche may have been a primordial asteroid that formed closer to the Sun than it is today, rather than the core of a protoplanet. Fragmented. The techniques described in this study provide a new insight into the asteroid surface composition. The team is now extending the application of these techniques to other large objects in the asteroid belt. That allowed the researchers to determine which pixels were captured that actually represent the asteroid's surface.